So today we are talking about the MCAT sciences, aka the SIRS, as opposed to the CARS that you'll find on the MCAT. So now we're looking at the structure for the science sections. Chem Phys comes first. For most people, this will probably be the hardest of the three science sections, but not always. I've seen people have difficulty with the biochem instead of the Chem Phys. Just kind of, it depends on your familiarity with the content. What topics are covered on the Chem Phys section, which is actually like chemical and physical foundations of blah, 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 like lots of crazy words to that name. But what do you think the sciences are that are covered on that one? Okay, chemistry and physics, but it's a little deeper than that. Physics for sure, G-Chem to be more specific, and O-Chem, and Biochem. So all three of the chemistries are on this section, as well as what other topic? What's sort of the topic that's on every section of the MCAT? The science sections anyway. Math and graphs, yes-ish. I'd say there's really no math in the psych-soc, honestly. But being able to look at figures, that's potentially one of the SIRS. Biology, yes. Biology is on all three science sections of the test. So it's sort of universal. There's not a huge number of specifically biology questions in this section, but there are some biology questions represented here. What's the difference in the biochem between chem and phys? Well, actually, I can point that out when we get towards a slide I have on the specific topics that you're going to generally be running into. So hang on to that thought. Once we get through that chem phys, then we got, of course, our car section. That is our morning. So once we get through the morning, you should have a break. What kind of a snack should you eat during that break? This is something I did not talk about on Tuesday. I will say straight up, don't bring a lunch. But nuts is good because that's like protein and maybe a little fat, low on the carb side. Energy bars, be careful with those things. Like, especially if you say energy bar, it probably has a ton of sugar in it. Is sugar going to be good for you for the second half of this test? No. Because what happens after you have like lots of carbs, like bread and cookies and things like that? How do you feel after you eat that stuff? Maybe like 30 minutes after. Yeah, you get that big rush for a little bit, and then I'm starting to drag a little bit, and you crash. You get the sugar coma going on. Minimize the carbs that you are ingesting in that lunch. That is actually kind of a big deal. And when you say energy bar, that's why that's not really probably the best thing you need. Even though they like say, oh, there's like 15 grams of protein in this energy bar. Yeah, but look at what else is in there. Look at the ingredients on those things. They are often loaded with simple carbs. You know, a good old-fashioned snack that is good to eat is good old raisins and peanuts. Apparently, you have a different name for that out here, but back when I was growing up, it was GORP, GORP, good old raisins and peanuts. I think they call it granola oats, raisins and peanuts here. But the granola and oats, do away with that. You don't need the granola and oats. You should have the raisins and the peanuts because fruit sugars are actually pretty good because they're going to take a little longer to process, and the nuts provide you a good protein source. Beef jerky, not a bad snack to have in there if you imbibe of the jerkies. So, but whatever you do, make sure to manage your intake of carbs at this time. So also for breakfast, don't be loading up on the toast and the oatmeal and the the like super carby nature that is the American breakfast. So like cereal, those are all things that lead to that energy crash in the first half of the day, and we don't want to do that. Then we get into the biochem section, 95 minutes again. And what topics are covered on this section? And we got the obvious two. I'll give those to you. Biology and biochemistry. What other sciences end up showing up in the biochem section? You can't have biochemistry without chemistry. Yes. Organic chemistry and general chemistry make their second appearance. The only subject that's on the biochem section that's not on the chem phys section is physics. There's no physics questions, no specifically earmarked physics questions in the biochem. So then we got another break. Then we get to psych soc. And what are the topics covered on psych soc? Again, we've got the two obvious ones, which is psychology and sociology. However, I will say this, there's almost no sociology on this test. If you take a psychology 101 class or psych, what do we call it? Just psych 1 here, you're perfectly fine because the sociology that is here is more like social sociology, or sorry, social psychology, which you do learn in the course of taking psych 1. So I don't think it's necessary to take Soc 3 to take the MCAT. I know that some people say you should take your Soc class to do this. There's not enough of it to matter. But there is a third science asked about on this section. What is that third science? Trying to give you a little hint. Biology. More specifically, the brain and the sensory systems, like the nervous system and sensory organs and how all that stuff works. Because you can't have psychology without, you can't have cognition without input. And so they do ask questions about brain function and the function of the nervous system and the function of sensory organs. More specifically, ears and eyes. They really don't bring in taste. They really don't bring in palpation, touch, and they really don't bring in smell. Mostly because those are much more complicated and distributed throughout the body for touch. So they're just really going to ask you about sight and sound. All right, then we get the void question. And I don't believe I mentioned the void question last time because I usually do that in this session. This is the big red shiny button of the test. How are you going to feel at this stage of the test? You just finished psych soc. You've been going all day long. You're going to feel good about how you just performed on this thing? Isabel's like, nope, it's bad. I'm going to feel bad. And so, yeah, it's going to be tempting. It's really going to be tempting to say like, oh, I did so bad. Should I press the button? Don't. Usually I'm going to say 99% of the time, people always underestimate how well they did on a test because of just self-doubt and frustration and honestly just lack of energy at this point in the game. There's only a couple good reasons to use the void button. The first is you get violently ill during the test. Like if you start coming down with something at the beginning and you were just like, yeah, got a fever and you're just slouching over and you're hot, cold, sweats, whatever, you're probably not taking the test at that point well. That's one reason why I would suggest people can't void the test. The other reason might be if you have sometimes, and this is obnoxious, but if the power goes out or the internet goes out or there's a weather alert or something like that, weather alerts not very common in California, but power and internet are, because that infrastructure is a kind of here, especially in Sacramento. That doesn't end the test. That doesn't like give you your money back. If it lasts for like only like 1 or 2, maybe 3 hours, they're going to have you wait there in the testing center and without your phone, mind you, you can't touch your phone because that's cheating. And you have to sit there and wait until things come back on. And how are you going to feel after sitting there? Let's say the power is out for 2 hours, and then you log back into your test, and there's a couple questions that you answered, but they don't show like they have answers because that happens. How are you going to feel about things? You going to feel positive the rest of that test? Remember also, you didn't have your cell phone to keep you occupied. So you're going to be frustrated and anxious and just developing anxiety throughout the entire time. That's another time I think it's a reasonable time to use the void button. The sucky part is the void test voids your whole test, but it still counts as one of your attempts and it shows up as an attempt. So you'll have a test with no score. So that's not the problem, but I think the problem is it counts towards your limit of 3 in a year. So if you void a test, you don't get a refund, and you have to pay for a brand new test, and it doesn't it just means you only have 2 more attempts in that year. So weigh the void button carefully. It's like I said, there's a couple good reasons for doing it. Most of the time, you're probably not gonna want to do it. Does that make sense to everybody? So after the void, you get the survey, and then boom, off with it. You just go. You don't have to do the survey. It's not really honestly, I don't know if they really use that information for much anyway. One thing I forgot to mention was the 10-minute optional tutorial at the beginning of the test. This is actually a really cool thing because I want you to all start the tutorial, but not do it. Just start the tutorial, and then you can skip through to the end and move on. But start the tutorial because it gives you a free 10 minutes to get yourself settled for getting into the Chem Phys section. What I mean by settled is, okay, you can adjust your monitor, you can adjust your keyboard, get it where you want it to be on your desk, figure out how are you going to place the scratch board on the test on the desk with the mouse and the keyboard, and get that figured out. If your chair has adjustments, get it adjusted and make sure your feet are flat on the floor and you've got a nice straight back and you're comfortable. You found that perfect distance from the monitor. So you have that opportunity during the tutorial to do this sort of get yourself settled and in the mode. Another thing you can do is do a little bit of, not meditation per se. I mean, if you meditate, do it. But just get your blood pressure to come down. And you can do that by taking a deep breath. And I want you to watch what my body is doing if I take a deep breath. So first one, or this one. What was the major difference you saw between the first one and the second one in my body? First one. Second one. And I'm exaggerating the breath sounds just so you can see it. What was the difference? Not seeing it? What are my shoulders doing in the first one versus the second one? My shoulders are moving. They're going up. I'm lifting my rib cage. And what does that do to your ability to inhale? Does it make it harder or easier to inhale when you lift your rib cage like that? Your intercostals are tightening up to do that. Am I getting more air or less air with the first way? And Kunga's right. The second one, I'm breathing only from my diaphragm. That's important. You want to teach yourself how to do diaphragmatic breathing to calm yourself. You do the whole chest movement thing, you just shrunk your rib cage. The intercostals contract to do that. You just shrunk your rib cage. You actually reduced the space for your lungs to expand within. You get less air, and it usually actually raises your blood pressure to do that. So if you've played a wind instrument or are a singer, you know how to diaphragmatic breathe. If you don't, go online, look at like yogis do this. A lot of people can have videos online about how to breathe diaphragmatically. I think it's an important skill to learn because you can drop your pulse and your blood pressure pretty dramatically by just a couple of good, solid diaphragmatic breaths. And that's what you need before this test. You need to go into this thing calm, not stressed. And another thing you can do in the optional tutorial is this. I call it the brain dump. You have your scratch boards with you right now. If you struggle with certain things, create yourself this sort of default template in your head and rewrite it and rewrite it and rewrite it until all you would need to do at this point for Chem Phys is just write a bunch of those equations or draw a couple pictures that help me remind me of things or whatever on your scratch board before you end the tutorial. It's kind of a free time to do that. Now, I've seen it only happen once where a student actually was told they couldn't do that. Every other time my students have done that, I've never seen them get called out on it. So it's a nice little way to give yourself a cheat sheet at the beginning of the test just for memory. But that means you have to have done it repeatedly. So it's just sort of muscle memory that's having the stuff come out. These are all things that the tutorial should be used for. Once you're done with that, move on, get started with the test. And there you go. So that's the overall structure of the test. That's what you can do, what I would want you to do. What are the SIRS? So much like the CARs, the critical analysis and reasoning skills, the SIRS are actually typed in correctly here, gosh darn it, and they are the scientific inquiry and reasoning skills. So if you spell that out, scientific inquiry and reasoning skills, you will see that it spells out SIRS. If I had spelled it correctly in here, which I'm going to correct right now, just to prove that that's what it does. Scientific inquiry and reasoning skills. And much like the CARs, there's very specific skills they're asking you to stretch when they do these. So number one, knowledge of scientific concepts and principles, about 35% of the questions. I think of this as a third of the sections. And what this is, I call these memory questions. These are the regurgitation kinds of things, or the problems where you have to remember an equation to answer it, or you like need to know, oh, that's this kind of muscle cell, that's not this kind of muscle cell, or it's this hormone, not that hormone. These are the things that are pretty much going to come straight out of your brain from like maybe rote memorization or repeated practice if it comes to like an equation or something like that. So that's our first type. Notice it's only about a third of the test. So thankfully, that's actually important, I think. It's only about a third of the questions. The rest of the questions, you get to use the passage and parts of the passage to answer those questions, which gets me to this point. The MCAT is a mile wide science-wise, but only an inch deep. So they're going to give you a lot of information on these passages. You just have to remember to use it. That's probably the biggest takeaway about science is you don't have to know everything under the sun, regardless of what videos on the internet tell you. We'll talk about that later. Second type, scientific reasoning and problem solving. These are what I like to call the passage-based questions, and it's about 50% of the questions on the section. And passage-based questions are ones where you got to take something you know, combine it with something on the in the text itself, like literally in the text, and put two and two together to figure out the answer to the question. So the first kind of memory, these are passage-based questions. I'm going to jump to the fourth type real quick. These are sort of the equivalent, but what am I looking at rather than the text in the passage for type 4? Not looking at the words anymore, the paragraphs. What am I looking at for number 4? Tables, figures, and graphs. Correct. So I'm looking at the pretty little pictures. So these are often very challenging for people. A lot of people on figure-based, as I like to call these figure-based questions, struggle with intimidation. of like looking at a figure and going like, there's so much going on. How do I figure this out? We'll have a whole section on that alone. But the one thing I can tell you now, it's all about intimidation. Figures don't tell you that much. They don't tell you 8 billion relationships. They tell you maybe 1 or 2, possibly 3 if it's a complicated figure. But that's it. So you've got to sort of downplay the relative complexity of figures. Usually what you get out of a figure is what it doesn't say. It doesn't, like, what relationships does it not give you, kind of thing. So I call those the figure-based questions. And then finally, we have our experimental questions. Reasoning about the design and execution of research questions, which is, again, also another 10%. And these also get people, because unless you've taken Psych 41, anybody here take Psych 41? Good. That's a good thing, because these are the Psych 41 questions. Like, what kind of a study was it? What was the control? What was the control condition? Was it a positive control? Was it a negative control? A lot of y'all didn't even know there was such a thing as a positive versus negative control. And that's what is covered in Psych 41, is a lot of that kind of stuff. So unfortunately, you might have to do some learning to understand some of these questions, like learning how to like bias and experiments and all kinds of stuff. But again, we're going to have a whole session devoted to that type of question, because it's something, unfortunately, that you don't get a lot of times. And thankfully, for the first time in history, in 2015, they added ethics into the MCAT. Before 2015, if they said, what's the best way to determine if this virus causes that disease, the correct answer used to be infect an organism with it and see if it gets the disease. Is that an ethical answer? Should you go around infecting people with viruses? No, don't do that. So that used to be the correct answer. Nowadays, you have to take into account that that is just ethically compromised, and you shouldn't be looking at that. Like, is it an effective way? Yes. Is it an ethical way? No. So you do need to consider ethical considerations, especially when it comes to psych-soc, because they often bring up the ethics of human-based research in the psych-soc section. So that's something that pops up on the exam now. So those are our SIRS. So the first type, what kind of those are they? What kind of questions are they? Are they memory? Are they passage-based? Are they figure-based? Or are they experimental? First kind are memory questions. Memory questions. They're coming out of here. Second kind, memory, experimental, figure-based, or passage-based. Those are my passage-based questions. So I'm going to use something from here and something from there in the paragraphs. Number 3, what type of those questions? The remaining 2 are experimental and figure-based. So I'll take research. These are the ones I'm going to be referring to as experimental questions, because they're talking about how the research is done, the experimental steps, the experimental design in the experiment, and flaws potentially with that. And finally, our last type, which is going to be the figure-based questions. Now, it seems to me like figure-based questions and experimental design questions, they're surprisingly not very much on the test, but they are. It feels like they're overrepresented compared to these percentages. I feel like it's more like 15%, 15% rather than what they say. Like, this has been that number that they put together in 2015. And I think the test has actually pivoted a little bit, and that percentage has gone up. I really do. Especially in certain sections. There's definitely more figure-based questions in certain sections, particularly the biochem, than there are other types of questions, or like than that 5 or 6. So the test mutates, it evolves over time. That's one of the ways I think it has evolved. So these are the official numbers, but I don't think they're actually what is happening anymore. So what science is tested on the MCAT? So here's just a sort of a quick rundown of some of the topics you need to make sure you're familiar with. A favorite, like the ones in blue are favorite topics. Like they show up and they show up a lot. The other ones, they show up. So enzyme kinetics, that you're going to see that more often on the Chem Phys part of the test, where they do enzyme kinetics types questions. Because what do they get to mix it with? They get to mix it with mechanisms. They get to mix it with organic mechanisms, and they get to mix it with kinetics like rate laws and stuff. So enzyme kinetics tends to be more focused into the Chem Phys. Metabolism, that one's probably going to be mostly biochem. Central dogma, definitely biochem, and they love the central dogma questions. Everybody know what I mean by central dogma? DNA to RNA to proteins, yeah. So, and then protein trafficking seems to come up a lot of like that it's questionable of whether that's biochemistry or more cell biology, but I put it here under biochemistry because it tends to come up in that fashion where they're talking about like, okay, the polar or the non-polar sequence that gets added into your protein so that it'll attach to the pore of the ER and stuff like that. So they tend to go a little bit biochemy on it. General chemistry, you're going to see atomic molecular structure, but that's not as heavily weighted as IMF. You're going to see IMF all over this test because it fits in biochem, or it fits in biochem, G-chem, organic chem, physics, and biology. So it's a universal topic. States of matter, like understanding the difference between liquid, solids, gases, and knowing your gas laws, not as big of a topic. Kinetics and equilibrium, and again, you're going to get hammered with that kinetics equilibrium stuff. Acids and bases, massive. Because what is biochemistry and organic chemistry? It's just applied acid-base chemistry. So, and then electrochemistry, not very much. People get really freaked out about electrochem, but it's not a huge topic on the test. Organic chemistry, I'm going to hear cheers through the internet on this one. Nomenclature, you got to know some nomenclature, but it's not like directly tested a lot. Isomers are knowing like difference between diastereomers and enantiomers and cis and trans and RNS and E and Z and DNL and levorotatory, dextrorotatory, plus and minus, all these different terms that go with stereochemistry. Properties of functional groups, reactions and mechanisms, not so much. That's where the cheering should fall. There's probably about, I'm going to say, 2/3 of the reactions that you learned about in OChem that are not at all necessary here. At all. Like alkenes, alkynes, benzene reactions, cycloaddition reactions, like a massive amount of these reactions are not necessary. You do need to know elimination and substitution, and you do need to know reactions of carbonyls and reactions of ketones, aldehydes, and reactions of acid derivatives. That's the only reaction mechanistic-y stuff that are retained from organic chemistry class. So a bulk of it, especially, thankfully, the bulk of retrosynthetic analysis stuff is thrown out because they tossed retrosynthetic analysis. You're not going to have to answer questions about like, what's the reagent that's required to do these 3 steps to synthesize that and turn it into that. They might ask you if it needs an oxidizing agent or reducing agent, but all the memorized reagents are pretty much thrown out the window, thankfully. And then separations identifications comes up a lot in both sections, Chem Phys and biochem. And I lump into that also the biological separations and identification techniques, including things like gel electrophoresis, PAGE, basically, things like blotting experiments, things like immunoglobulin assays, ELISA. So those types of things I would lump into separation of identifications, and you will see different companies' books putting it in different places. Some companies put it in biology, some companies put it in OChem, some people put it in biochem, some companies split it up all over the 3, and it's hard to find it all in one place. So that's, again, something you might have to do a little footwork to really get a good handle on so you can be thinking about it the right way. Physics, kinematics, pretty hard to ask a kinematics question on the test anymore, unless you're talking about like something like projectile vomit. So projectile motion of vomit, I guess. But knowing your big five equations for kinematics is, you need to know them, but you're probably not going to apply them much. Forces, once in a while you'll see a force question: Newton's first law, Newton's second law, gravity, friction. What's more common is work energy theorem. So work is delta KE, work is negative delta PE, which is the one you probably didn't remember when I said work. You probably were thinking work equals FD cosine theta, but that's not the right one because it's barely ever going to get used. Fluids, light and sound, why are those emphasized? Those are all things that can get incorporated into what? What other subject? Biology, yes. So you have a lot of, like, the body is fluids. There's light, eyes, how the eyes work in with wavelengths of light. Sound, where you're going to have to understand how sound waves work because the sound wave might get here and be a different frequency, blah, blah, blah. And then light, I was going to say, oh, respiratory system, the circulatory system is a lot of fluid dynamics goes in there. Biology, genetics, it's pretty much you're always guaranteed a genetics one-off question, like maybe one or two of those where you got to do something like with a Punnett square or oh god, I always forget it. The population genetics. What is it called? Harvey Weinstein? No. Harvey Weinberg. Harvey Weinstein's the dude, isn't it? I can't believe that came out. Yeah, Hardy Weinberg equations, knowing that. So like they're just one-offs. They're not going to be very tough. Micro, big time. They love their bacteria. They love their virus questions. Cell bio, like a little bit of cell signaling occasionally, a little bit how cells replicate and all that fun stuff. Anatomy, I was trying to figure out a way to de-emphasize that. You barely need anatomy for this test. So if somebody told you needed to take CHA 101 or whatever that class is to do well on the MCAT, they were lying to you. You do not need anatomy for this test. You need to know physiology. Physiology is the monster on this thing because you got to know the physiology of all the systems, hormones, signaling with hormones, like what hormone does what stuff. Like there's a table in your book which is just a list of hormones and what they do and where they act and where they get produced. So hormones, big deal. Physiology, big deal overall. Psychology, it's kind of weird how like psychology split up. It's mostly about behavior and perception. So they'll give you like something involved in biology to get into the perception questions, memory a little bit, but they really love their stages questions, like this person's stages of development, development of cognition. I forgot to put cognition on here, actually. Cognition is another common topic. Slap it in here real quick because that way it'll make it into the video. So behavior and cognition, both of those are going to be big topics. And then self-identity, not as much. This is where you also will get the sense that all they're doing is asking you about a whole bunch of dead people's names and how they fit to theories. It's probably one of my least favorite aspects of this part of the test is that it really is, in a lot of ways, regurgitation more so than any other part of the test. You do need to know who the people are associated with the different theories, the different ways of thinking about things. So, for example, they might ask a question about how an emotion is, how an emotional response occurs. You might remember there's the Schachter-Slager theory, the Lazarus theory, a couple other theories about how perception of emotions. They will say, which of the following theories, and just list the names, is most consistent with the experiment done in the passage? I personally hate that kind of a question because I don't remember those things, because I'd rather just understand what's going on. But here's a trick I've learned over the years when studying for that is, instead of studying from like a book, or like you have the big set of notes from Kaplan, or from not from Kaplan, Khan Academy, the 300-page set of notes for Psych Soc, which some of you probably stumbled upon. I don't think that is a good way to do it, because it doesn't give you the compare contrast you need. I would encourage you to rewrite a lot of your Psych Soc notes into study guides that are tabular. Like you've got 4 different theories about the same thing, and you write like the similarities and the differences, or you maybe write it as a figure that compares the different steps and in what order. Or maybe you have the different stages and what ages of each of those different development theories right next to each other. This is a much, like, doing visual organizer of this information is going to be so much more helpful to you than just memorizing copious pages of words, because of the way the questions are asked, basically. Soc, there's maybe 8 Soc questions on the whole darn thing. And like I said, they're mostly social psychology type questions. And so you got social structure being the focus, a little bit about cultural structure and cultural inequality. And you'll see those come up. For the most part, Soc is not really a big topic here. The psychology is much more important, and you need to study like it's a much more important topic. So that's a rundown. Does that answer your question you had earlier about like how does the biochemistry split? All right. So all this to say, one more time, the test is a mile wide, but how deep? An inch deep. You got to be careful of those resources out of the internet that go into great detail. One that I can think of right off the top of my head is Sketchy MCAT. It's a funny name to me because it sounds like it's terrible. Sketchy MCAT, you might have heard about. They have sketches basically to teach the content. The thing I think is that I'm warning you all about is it's super dense, because those videos were originally created for USMLE. They are going way down that rabbit hole, far more than an inch. They're going like 1.5 feet down the rabbit hole. You don't need that level of knowledge for the MCAT. So just buyer beware. Like when you're looking at these things, you don't need to have that great of a depth of knowledge. So another place where that happens is Khan Academy, because many of those Khan Academy videos that are still available, they weren't actually specifically for the MCAT. They took like a chemistry classes videos and rebranded them as MCAT. Again, like a lot of them focus way too heavily on math. There's very few questions of math, like maybe 8 math questions test wide. So all that stoichiometry, all those complicated calculations that you did in a GChem class, and what they do in a lot of those con videos isn't what the MCAT's about. It's not really something you have to worry about. Do you need to understand stoichiometry? Yes. You need to be able to do really complex, long questions with stoichiometry? No. Same with physics. You're not going to get really complicated physics math questions. It's usually like a multiplication here and a division there, or plug it into a formula here. And that's about it. So mile wide, inch deep. Watch out for those sources that tell you it's worse. So what is the timing of the SIRS sections? You have 95 minutes now and 59 questions. So there's more questions here. You get 10 passages, but they're all shorter. And most of your passages are going to be 4 minutes, or sorry, 4 questions. And then there's several 5s, and then there's only 1 6. And then on top of that, you've got 4 sets of discrete questions. So there'll be like 3, 4, 4, 3, or something like that distributed throughout the section. They always fall between the same passages. As a general rule of thumb, you should be approximately using about 1.5 minutes per question here as well. But look at the times on those passages. Are they better or worse than cars? They're worse. You have less time for any given passage on the science section, here is something here's the big secret, in my opinion. Don't read the science passages. Cars, do what you got to do. Science, if you're reading the passages, you're robbing yourself of the opportunity to answer the questions. It is much easier to cherry pick out of the science passages because most of the things you're looking for are going to be abbreviations or very clear word patterns and things like that. So I'm telling you, I think everybody here should cherry pick in the science. Just go right into the questions, go back to the passage when you need something instead of read the passage, do the questions, go back and find that thing you need. Because the most of the time, most of what you're getting is very easy to find, or it's just straight up in a figure. So the passages aren't super useful here. Tools, the same tools as you're going to get for the car section, except you get the addition of having a periodic table. So you got the periodic table. When you're studying, don't have your periodic table just sitting out right next to you. Because what that does is it creates it doesn't make you remember, I have to go look at it when I need it. So put it under your book or put it have it, face down or something so that it forces you to remember, I got to go look at that. So I have to actively go Alt-T to find it. So just keep your periodic table nearby, but face down. That way you practice having to figure out when you need the periodic table. Otherwise, you'll forget to use it. I've seen it happen a million times. So scientific reasoning. It's very similar to what we talked about with cars. Decoding, fluency, vocab, reasoning, working memory, attention, logic is a much bigger thing here because you got to use your scientific logic, figure analysis, which is something we're going to practice in this program. But I want to come back to vocabulary and fluency. It's a big deal for cars. It's an even bigger deal for science. What the heck do I mean? I think the biggest weakness people have coming out of science education is I just don't know that vocabulary building has ever really been a focal point of many teachers out there in the science realm. But one of the reasons why people do or have a really difficult time with organic chemistry is because it's language. You are learning a completely new language. If I say the word ester right now, do you think you could draw me an ester? Okay, one person's confident. I'm not sure what that means. It looks like a bat. Can somebody decode that one for me? Maybe it's a mouth with two eyes that are closed. What do you mean probably by that? Do you mean yes, you can, or no, you can't? Or is that supposed to be a sad face? It's a sad face. So, okay. I think it finally dawned on me what it is. I would say with the hesitancy in answering that question that most of you probably don't have a very strong mental picture of your organic functional groups. That's a problem. It's not it's not your fault. I guarantee you 100% that is not your fault that you have that problem. What it's coming from is it wasn't a focal point. You were just assumed you would be able to figure out what a freaking ester was. Same with your acids and bases. List for me all of the strong bases you can think of. Let's see if as a group we can come up with what I would consider the 6 strong bases. Okay, there's one. That's actually the same one because it's OH minus. Hydroxide is the strong base part. The metal doesn't matter. Anybody else got one? NH4 plus is an acid. That's all right. I'm putting you on the spot. NH3 is a base, but it's not a strong base. You're out, aren't you? I think everybody in here is probably out. How am I calling this vocabulary? This is actually vocabulary because in a way, you're missing the words to recognize, like in a reaction, when I look at that reaction, that's a strong base and it does this thing. That's a strong acid, it does this thing. This is a weak base, this is a weak acid. And without that, you really, really struggle to be able to answer questions. Because the hydroxide is the basic thing. OH minus, that's the base. The metal is irrelevant. It dissociates and hangs out in the solution somewhere. So for strong bases, you'd be looking at OH minus, NH2. Whoops. Oh, sorry. I'm trying to type them in the chat box, but it was broken. OH minus, NH2 minus, OR minus, and R2 minus, H minus, and R minus, carbanions, aka Grignards. Massively strong bases, which is why you can't use a Grignard in a protic solvent. So again, it's this deficiency that has sort of been systemically built into you, which makes it harder to understand the question. So this is something you have to work over. In physics, what's our vocabulary in physics? Lots and lots and lots of units. Actually, I like that. Units are important. I would say units have to go along with this other thing. E equals mc squared, E equals hv, C equals lambda v. Equations, formulas. That's your physics vocabulary. Without that vocabulary really well cemented, even if you saw a question on that you need to calculate power, if you're not able to recall quickly power equals work over time, or recognize that power is in units of watts and work is joules and time is seconds, you might never realize that that's how you solve the question. Formulas and units, equations and units, that's your physics language. What about in biochemistry? You literally have a language, A, D, E, G, Y, Q, F, amino acids, your bases, the sugars, like glucose and fructose make sucrose, glucose and glucose make maltose, and glucose and galactose make lactose. That's vocabulary again, in a way, because without those basic things taking up residence in your head, it's difficult to find the question. It's difficult to answer the question. And then biology, your language, your vocabulary to practice, honestly, I'm just going to say hormones. I would call that the vocabulary you need to practice in your biology. Learn your hormones so well, because many, many, many questions hinge on hormones, even if they don't look like it. Then, of course, for psych soc, it's like all those comparative theories, knowing the names of the theories with what is in the theory. So I call this vocabulary because in a very real way it is. Because if you're missing that piece, it doesn't matter how well you understand a concept. If you don't notice the words being given to you, it becomes very, very difficult to access that knowledge and use it and apply it to the question. Everybody clear on that? I know I'm like beating a dead horse here, but this is so important to everybody's future on the MCAT. Yeah, good. All right. And asking questions is honestly so much more important here too. Literally, the first thing I do when I read the question stem is I will say, where is this information? I literally say that to myself every single time. Like if you've ever done a practice passage with me, practice science passage with me, which I'm not sure we're going to have time to get to today, just because this one was always a longer presentation, but we should probably be able to. So if you ever do that with me, what you'll end up hearing me say almost every single time is, tell me whether you find that information. Is it in the passage? Is it in a figure? Or is it up here? Ask those questions. Ask those questions. What does the figure tell me? What are the figures not able to tell me? What is the difference here versus what I like? It's these questions which are going to make you that better test taker, because you're doing the compare contrast thing, and you're actively going after that information rather than sort of passively hoping it seeps into your brain. So what am I saying, really? Am I saying the science sections are also reading comp sections? Yes, 100% yes. Is the MCAT a science test, or is it a reading comprehension test? It's a reading comprehension test. For all intents and purposes, that's what it is. I would never say that about the DAT or the OAT. The DAT and the OAT are not reading comprehension. Those are regurgitation tests, which a lot of you are more comfortable with, because you just know a thing and bleh, pick the answer. Look at it, pick the answer. Look at it, pick the answer. This is a very reading comprehension driven test, to the point of, if you just focus only on science rather than strategy and how to approach questions, even in the sciences, here's what's going to happen. You're going to get to a 500, maybe 501 or 2. You'll get up there, and then all of a sudden it's going to start doing this. Your tests are going to go up and down and up and down, and then you're going to get frustrated, and it's going to start going down. You're going to get what I like to call the plateau, and eventually, just like the Michaelis-Menten curves that go up, hit the plateau, and eventually drop off. That's what tends to happen to your score. It's very frustrating, and it's a product of you having been tested the way you have been your whole lives. You've never been taught how to do a reading comprehension test with science on it. So it's a learning curve. What is the most important thing I can tell you to do when studying your science? Don't just read books and watch videos and take notes and flashcards and stuff. That's like half of your job, literally only half. The other half is doing practice problems, practicing the reading comp skill, practicing diagnosing what does that question need me to do, doing all those things. Because without it, your score is probably going to plateau around 500 or so, and you're going to have a hard time getting past it. It's the key. It's the secret. This is the secret sauce, I'm telling you right here. This is how you beat the test. Learn that it's not a science test. Everybody got it? All right.